This conference will now
So
be
we have
recorded.
logged in community dot website databricks.com because our free subscription is not supporting to create a clusters. So I hope everyone has created yesterday the account whatever we have over here. So let me log into this community dot. So you need to create community dot cloud.databricks.com, or you can directly go over here community cloud dot databricks community edition dot login over here. So I'm going to log into this databricks https community dot cloud dot databricks.com. So simply click on here. So here you can able to put your email address and password whatever to log in. So I'm going to use sign in over here. So inside we are going to create the clusters, and I'm going to write down the notebooks. So from where you are going to take the data to perform this. Before that, I want to create a cluster first. Go to the compute. Yesterday we created one cluster, right? So what I want to do, I want to delete this cluster and I will create a new cluster. So simply delete this existing cluster and I want to create a new cluster. Create a cluster. This community edition will support to create only one cluster at a time. The cluster name is eClasses cluster. Click on create. So by using this eClasses cluster, I'm going to run my notebooks. So inside the notebooks, how to write down this PySpark code, Python code. So what you are trying to do, we are trying to run a simple commands. The simple commands I'm going to run over here. So let me go to the already existing notebooks, whatever I have written earlier. Simply go to the recent, and there we have, I can see, go to this one. Let me see this one. All right. So this is the simple notebook we are writing over here. If you want to print anything, just simply write down print, and in the double quotes you need to give a open and close bracket. To run this command, whatever you are writing, definitely your notebook should have a cluster. So I'm going to map a cluster over here and simply click on run this cell. So click on this, run this cell. So it is going to execute whatever the command you have written, and that command we are going to print over here. 1 2 3. Okay, print double quotes 1 2 3. All right. So this is a simple basic command. So, but now my requirement is I'm going to store some file inside my Databricks itself. So Databricks contains some kind of storage as well. So you can able to create one table structure data, and that data also you can able to read over here. So how to upload a file inside this Databricks, I will show you. So simply go to the community.databricks.com. There you can see there is a data pan. So either you can take the data from outside of data sources, or you can use the internal storage of the Databricks as well. Data. Okay. So first we will use the existing data, whatever we have inside this Databricks, to practice the PySpark commands inside the notebooks. So let me give you one sample file as well. So I have a file batch 40 user data.parquet file. So Parquet file is a kind of file storage like our CSV file, our text file, our Excel file. Parquet also is one of the type file. So this Parquet file having very advantages. So what are the advantages of the Parquet file? What is the advantage of this Parquet file? Parquet is open source file format, column oriented data storage format. Okay, it is similar to the column storage file format available in Hadoop, and it is more compatible. It is more compatible with the most of the data processing framework like Hadoop. So the Parquet file is more performance also. Apache Parquet is designed for efficient as well as perform flat columnar storage format data compared to the row based file like CSV or TSV files. Parquet can be only read the needed columns, therefore greatly minimizing the input output processing time. So this is definitely more faster to read the data. Okay, so this is one important interview question in the Databricks. What are the advantages of the using Parquet files? What are the advantages of the using Parquet files? Okay, so Parquet files are more suitable for the processing of the or storing of the big data in a column storage format, and it is more efficient to read the data and minimizing the input and output processing. It is minimizing the input and output processing. What are the advantages of the Parquet file? Okay, so you can write down those 2 points. It is storing the data like a column storage file formats available in Hadoop, and it is compatible with most of the data processing frameworks. Okay, it is reading the needed columns only. Okay, so I have one Parquet file uploaded inside the data pan. Let me show you. Go to the data pan. Under the data pan, create a table. Go to the DBFS. Under the DBFS, you can see file store. Under the file stores, you can go to the tables. Under the tables, batch 40 users data, batch 40 users data.parquet file. So this file contains some data. So that data we are trying to read into our Databricks notebooks and performing some kind of transformation techniques over there. Okay, how to upload a data into this location? Simply you can go to the upload a file over here and click on select the file. So where is your file located? You can drop files upload here from your local computer. If you want to upload a file, so simply you can go to the data pane. Under the data pane, click on create table. Under the create table, upload file. Under the upload file, drop files to upload or click to browse. Okay, so simply click on, so whichever the file you have. Under the downloads, I have these Parquet files. So if anything, then so I don't have file. Yeah, batch 40 user data.parquet file. So this file you can able to upload. Once you are uploading, that file will be saved into the DBFS, Databricks file system. Under the DBFS, under this file storage, under the tables, it is going to store the data over here. Batch 40 user data.parquet file. Clear? So once the file has uploaded into the Databricks storage system, so I just uploaded a file into over here under the Databricks data storage. Why I uploaded a file here? Because just I want to by taking some sample data over here. So that sample data whatever I have uploaded, the sample data whatever I have uploaded, so that data I'm going to use inside these notebooks to run my commands. Okay, so once the file has uploaded into the Databricks, how to read that data? So what kind of commands you are going to write down over here? So let me go to this the batch 40 book or whatever recently we have used. See how to read a data. So I'm trying to read the data from a file. Which file? Batch 40 users data dot parquet. Okay, batch 40 user data dot parquet. So whatever this batch 40 user data dot parquet we have over here, inside which location? In a tables where it is under a file store, right? So we have uploaded under file store. Under the file store we have a tables. Under that, batch 40 users dot parquet file. Batch 40 users dot parquet file over here. So this, in this path we are going to store the data. So this is spark dot. What is the command we need to use to read the data from a file? Spark dot read dot. What is the extension of your file? If it is a CSV file, then specify .csv. If it is a Excel file, you can specify .xlsx. If it is a tab separated file, specify .tsv. Okay, it is a Parquet file, so that is the reason I'm specifying Parquet file. So whatever the data we are reading over here, whatever the data we are reading over here, whatever the data we are going to read, so where we are going to store this data? This data we are going to store into a data frames. So what is a data frame? What is a data frame and RDD? So generally earlier to these data frames, we have a RDD. RDD stands for resilient distributed. RDD stands for resilient distributed data. Okay, so by using this RDD, earlier days we are storing the data whatever we are reading from here. Whatever the data we are reading, we want to store temporarily into this RDDs, like a temporary tables. In SQL terminology, we are calling this as a temporary tables. So what we are going to do over here, by using this resilient data, so resilient distributed data set. So this, what is the features of this RDD? So whatever the data you are going to read from the files or whatever, if you want to store temporarily into a particular block, then you have to use this RDDs. So RDDs having, this is something like a data structure. So whatever the data you are reading, you can store inside this like a data structures, and this is RDD having some features like immutable and fault tolerance. So what is this immutable and fault tolerance? Immutable means once you are creating this RDD, so now I'm going to read a data and assigning that data into an RDD like one temporary table, then you cannot change or you cannot modify or you cannot alter that RDD. The data what you are putting inside that RDD, you cannot modify. That is called immutable. A RDD is a immutable. RDD is a immutable and it is a fault tolerance. Fault tolerance means at any case, your RDD while you are reading the data from your cluster nodes, RDD got failed. I mean, some cluster nodes are failed, even though other nodes of your cluster will be reading this data. That is called fault tolerance. It will never fail to read the data from these RDDs. Okay, each data set in RDD is divided into a logical partitions. What will happen when you are storing the data in this RDD? It will be distributed the data into multiple nodes. It will distribute into multiple nodes of your cluster. So a RDD is a data set, immutable and fault tolerance. We are storing the data whatever we are reading temporarily into this RDDs. After these RDDs, earlier days we were using these RDDs, but later PySpark has introduced data frames. What is a data frame? It is completely a structure like your tables. A tables contains columns and rows. A table contains columns and rows, right? So similarly, this RDD also, this data frame also contains the structure of the data in a tabular structure format. Okay, so a data frame is a distributed collection of data organized into a columns and rows. It is equivalent to a table in a relational database management system. Data frame is a distributed collection of the data. Data frame is distributed collection of the data organized into data frame is a distributed collection of data organized into columns and rows. It is more similar like a table in RDBMS, like our SQL Server tables. A data frame is, and what is the advantage of these data frames comparing to this RDDs? So the advantage is PySpark itself optimizing the data frames to read the data more faster, to process the data. But RDDs are not optimized automatically. So data frames will be optimized automatically by your PySpark while you are processing and reading of the data over here. Okay. So then how to create a data frame? So we are creating a data frame. By reading the data from a file storage. Can I create a data frame with manually by entering some data? Yes, you can able to create. So how to create? So let me add one more tab over here. How to create a data frame? So to create a data frame contains some named columns. Specify those columns. So what are all the columns you want to keep over here? So I want to keep employee number, put in double quotes, and I want to put employee name, comma, employee name, comma, salary. Employee number, employee name, salary. And also you should have some data, right? So then you can specify some data also. You can give any name. Here you no need to give columns. You can give anything. This is just a variable. And here you can give any name. So data equals to, and you need to specify the data. So the data I'm going to specify employee number 100, employee name Ram. You should put in double quotes, and salary 1000. And similarly one more employee details I want to enter, comma, put in 200, Vihan 2000. Okay. So now by using these columns and data, I want to create a data frame. So how to create a data frame? Data frame name you can give. Any name you can give. I'm going to give it as a RAM data frame. RAM data frame equals to. How to create a data frame? You can use spark dot create data frame by using the data. So what data you want to keep inside this data frame? Let me use this as a different name, rows. So data equal to ROWS. Whatever the data I have inside these rows, I will keep that one. And schema equal to columns. Right? Columns means whatever the variable name we have specified here. These are the column names. These are the rows data what we have. RAM df equal to spark dot create data frame, data equal to rows, schema equal to columns. Okay, so let me create this one. Run the cell. Spark session object has no attribute. Create data frame. Okay, there is some case sensitivity. Spark dot create data frame. Run the cell. Okay, employee number, employee name, salary. All right. So this is the data frame it has created. If you want to see what is the data, what is the schema of your data frame inside you have, then simply you can go to write down a statement. So how to see the data what we have inside this data frame is add one more command like display. What is your data frame name? RAM data frame. So let's execute. See here. So this is the data I have inside this data frame. Okay, you can use this command display RAM df, or you can use the other command like RAM data frame dot show. You can use this one as well. Run the cell. So this is displaying the data like this. So this is how a simple data frames we can be created. Data frames are simply storing of the data in a object model. Storing of the data in a object model. By using a create data frame, we have created one data frame over here. Spark dot create data frame, data equal to rows, schema equal to columns. And if you want to see the schema, means what are all the columns and what are all the data types, everything you have. In that kind of situations, you can write down another command like your data frame ram df dot print schema. Print schema ram df print schema. Run the cell. This is your schema, like what is your column name, the data type, what is the another column name and the data type, what is the third column name and the data type. Clear? So this is manual creation of a data frames. Generally in our SQL server also we are inserting the data, right, by using insert command. We are creating a tables, and inside the table we are inserting the data. The same way here also I have created one data frames. The entire PySpark is running on the data frames concept only. Data frame is a a distributed collection of data. Distributed means your data will be distributed among multiple clusters, because the data while it is going to store in the multiple clusters, it is going to store while it is going to process. Okay, it is not under one cluster. So columns equal to employee number, employee name, salary. Rows data, I'm going to specify this one. Then I'm creating a data frame by using spark dot create data frame. Data equal to rows and the schema equal to columns. Then it will create one data frame. If you want to see the schema, what data you have inside, sorry, what is the structure of your schema, you can use ram df dot print schema. Ram df dot show means the data what you have inside, it will display. Similarly, you can use this command as well. Display what data you have inside. Ram df. Execute this one as well. Okay, so whatever the data you are displaying here, that is displaying by default in a table structure. Or if you want to display in any other bar chart or scatter chart, any charts also you can able to display. See here, chart format. Ram, how much salary? 1000 rupees. Vihan, 2000 salary. So I want to display the data in a table structure only. Okay, so this is a manual creation of the data frames and storing the data. Yes, as many data frames you can able to create. As many data frames you can able to create. So instead of creating a manually by inserting the data, I have already some data inside a file, that is batch 40 user data dot parquet file. Inside this file, whatever the data I have, I want to read that data and assigning that data into a data frame. So what is the name you want to give for the data frame? I want to give it as a ram data frame 2, because you cannot use the same data frame to recreate. So it is going to create a new data frame. So how to read the data from a file? Spark dot read dot parquet. Because my file format is a extension is a parquet format, that is the reason I'm giving. If it is a CSV file, I will give it as a CSV here, and I will give it as a CSV over here. So let me execute this one. Click run the cell. Right, so it has created a data frame ram df2, and you can see that information over here as well. Do you want to see the data what you have inside that one? You can write down display. What is the data frame? My data frame name is ram df2. Display ram df2. So click over here, run cell. This is the data we have. Do you want to see the schema? Then you can write down print schema ram df2. So this command you can able to execute it. So you can write down one command over here. Sorry. Data frame dot schema. Print schema. Ram df2 dot right. So both commands has executed. This command is displaying the data. This is the data, and this command, the second command is creating the list of columns. Creating the list of columns over here. Okay. So then on top of these data frames, you can add some transformations. Like for example, whatever the data frame I have, the data frame is returning these columns, because from that file we have taken the data: registration, date time, ID, first name, last name, email, gender, address, CC, country, birth date, salary, title, comments, all those things. Okay. So for example, from this data frame, so this data frame currently contains all these columns. If you want to drop few of the columns, I don't want like some of the columns inside this data frame, how can you drop that? Let's say for example IP address column or some other columns. If you want to drop, simply you can write down, what is your data frame name? My data frame name is ramdf1. ramdf1 dot ramdf1 dot drop the columns IP underscore addresses and CC. These two column names I am going to drop from this existing data frame, and whatever the output is coming from here, that I am going to assign to a new data frame, ram df ramdf2. So every time whenever you are doing the operations, we are assigning that data into a new data frames. Whenever there is a operation we are performing, that result after the operation performed, that result we are going to assign to a new data frame over here. All right, so that is ramdf2. Let me see the data after ramdf1 dot drop. Ramdf1 is not defined. Oh, it is ramdf2 actually. So then I will make this as a 3. Right, see here that IP address and CC has dropped out. Okay. Okay, so this is all about the today's session. So please practice by creating this account one by one, the commands what we are practicing over here. Try to understand and please make your own notes over here. Then we can meet tomorrow and let's continue about the other commands.